One of chemistry's favorite words is the mole. It's a very simple word to understand, yet it's kind of funny because it's one of the vocabulary words in my class that when you finish in June, if I ask you what a mole is, you have trouble articulating what the definition is. So listen closely so that you don't think a mole of something is hard to understand. The word mole is a counting unit that's used in chemistry in relation to the periodic table. Every time you have one of the squares of information, like if you look at carbon, there's some information in carbon square. It tells you that his atomic number is 6, tells you that his mass is 12.011. You've got all the carbon information in carbon square. And if I have one of these carbon squares, that's 1 mole of carbon. If I have 2 of carbon squares, well, that would be 2 moles of carbon. And then I could ask you questions like this. What's the total mass of 2 moles of carbon? What's the total mass of 2 moles of carbon? 24. The mass of 1 mole is 12, because again, when I say a mole of something, it just means 1 square of it on the periodic table. So if 1 mole is 12, well then 2 moles, there's my other one, would be another 12. So 2 moles has a mass of 24.022, all right? I don't mean to round and confuse you, but moles, rather, or grams in this case. Now, if I talk about moles of a compound, it works the same way. Like water, for example. Well, that's 1 mole of water. He's got a mass of 18.015 grams per mole. And that's by adding up his parts, molar mass, like we did last week. But real quickly, what if I had 4 moles of water? What do you think that mass becomes if there's 4 moles of water instead of just 1? You just multiply by 4, exactly. All right, so it would be right under 80. It looks like 72-ish, all right, by multiplying. So I just don't want this word to scare anybody because, again, it's simply a counting unit that describes how many of something that we have. How many nitrogens do you have? I have 7 moles of nitrogen. Okay, well, that's 7 squares of nitrogen. All right, how many moles of ammonium do I have? All right, well, that's 1. That's 1 mole of ammonium. This would be 4 moles of ammonium. All right, that would be 1 NH4. That would be 4 NH4s. Just simply our counting unit. What I want to show you today is a way that we convert between moles, grams, and atoms, actually. Now, atoms is one of the very first words I ever showed you, the smallest particle that exists in things. And we've got another funky number that comes along with atoms. In your notes, title this mole conversions. And right under that, we've got 3 magical numbers that I need you to write. I need you to know that 1 mole of something equals the periodic table grams of something, as I just showed you. All right, 1 mole of hydrogen has a mass of 1.008, because that's what the periodic table says. But the atoms are harder. Atoms are so tiny that there's millions of them in any sample of matter. And we've got a really special number here. .022 times 10 to the 23rd. This is called Avogadro's number. In middle school, you probably have seen it before. But it's an agreed upon value to represent the amount of atoms in 1 mole of anything. So it's an important number in regard to converting. Now, it's a huge number. For those of y'all that know how scientific notation works, this means you would slide that decimal to the right 23 times. And it would be a huge amount of atoms because, again, atoms are so small that if I have a sample of any type of matter, there's billions of atoms in here, which would make up for why that number has to be so big. These values will be given to you. Let me show you how we use them. Your conversion questions will be straightforward. They'll sound like this. Write this down as our first example. If I have 150 grams of O2, how many moles of O2 is that? You don't know that yet. How many, or rather, if you take a look at your cheat sheet, you will see this. It's a set grid that we're going to use to solve all of these conversion problems. The really good news about this skill is once you know how to use that grid for one conversion and you understand it, you can use it for all of them. So these don't really get more difficult or less difficult. You just got to be able to understand where everything goes. So you see that grid? You see what I'm talking about? We're going to draw. So let's draw this kind of exorbitant T. What I want to do is put letters in the squares before I put numbers in the squares. So if you take a look here, you see how we've got these bold units that it refers to? I want to put those in first. So if you look in this square in regard to your cheat sheet, it says given units. Well, look here. There's my given information. Here's my unknown information. Unknown because this is associated with a question mark. Given because that's a given number. In regards to looking at the info, I gave you a number, a unit, and a compound. All right, and I did the same over there for the unknown. So looking at our cheat sheet, it says the given unit needs to go right there. What's my given unit? Grams. It's the unit associated with the given number. So put grams in this square. You'll notice that this square is empty. If you look at your cheat sheet, I don't have anything in that square. So we will leave it empty. Let's move over to this bottom square. Again, what does it say goes in that square? In that bottom square? Look where I'm pointing. It says given units again. All right, well, that's a repeat. Well, what are the given units? Grams. All right, so far, nothing crazy. The given units go in that square and that square every single time. What goes up here? The unknown units. So I'm going to click over to this other set of info. What are the unknown units? Moles. All right, that's the unknown number, the unknown units, and the unknown compound, just like that. Moles. Sweet. We've got all of our non-numerical data in here. Now let's go back and put the numbers in. Looking at your cheat sheet, what number does it say goes here? The given number. Everybody see where I'm getting that from? Everyone see how your cheat sheet clicks perfectly to this? What's my given number? 150. All right. You see those two squares? What do they say? They say the same thing on your cheat sheet. They say conversion factor. Remember these numbers that we put across the top of your notes at the very beginning? Those are your conversion factors. These are the things that are set equal to each other that will make this conversion work. In other words, listen, most important thing I'll say all day. The numbers that you put in these two squares are always two of the three numbers that are up there. You see moles? Find moles up there. What number is associated with moles? Grams. Find grams up there. What number is associated with grams? All right, well, it didn't give us a number. It says periodic table. See that guy right there? We need to go and find his mass on the periodic table. So, he's O2. Oxygen has a mass of 15.999. There are 2 of them in this case. Somebody give me that value. He said 31.998. There's the periodic table value that we were looking for. 31.998. Solving the grid's very easy. You multiply across the top and divide by the bottom. Type that into your calculator. Multiply across the top and then divide by the bottom. You can do it all as one function. So I'm going to type 150 times 1 divided by 31.998. Go 2 numbers past the decimal. What do you get? I get 4.69 if you round properly. Now understand that this perfectly supports the definition of a mole. This says that 4.69 moles of O2 has a mass of 150 grams. Well, remember, 1 mole of O2 has that mass, because it's 2 oxygens has that mass. So this says that if I multiply that by 4.69, it would equal 150, which is absolutely true. So 4.69 moles of O2, if I have that many of them, it'll have a total mass of 150 grams. It solves the problem for us. Let's do another one. I'm going to leave this blue writing here so that your eyes can see it. It won't be there on your online assignment, but I want you to understand that your brain can always label the given and unknown information by that blue stuff. Write this down for our second example. 500 moles of helium is how many grams of helium? Draw your grid. What do we put in the squares first, letters or numbers? Always letters. If I come over and you've got numbers and letters written in this square and nothing in that square yet, I won't help you because you're not listening. I need letters, 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 then go back. Numbers, numbers, numbers. What letters will go here? Moles, the given units. The given units is moles. Nothing goes in that square, right? Nothing. What letters will go here? Moles again. Remember, just follow right along. Given unit, it repeats itself, right? The diagonals match the letters. What goes up there? The unknown unit goes up top. So just move slowly. I heard some of y'all whispered an incorrect answer under your breath. All right, move slowly. Follow your cheat sheet. Now let's go back and do numbers. What is, based off the cheat sheet, the given number? 500. What goes in those squares? Just generally. 2 of the 3 numbers up here. All right? It comes straight from the top. What number is associated with moles? 1. Always 1 for moles. What number is associated with grams? The periodic table. Now look, I gave you an easy one this time. It's just helium. What's the mass of just helium? 4 point what? 012? 003. Everybody see where I got these numbers from? Stop me if you don't. Multiply across the top, divide by the bottom, get an answer. What'd you get? 2001.5. What do you think so far? I can't make these harder. I can't do anything to make there be extra steps or, oh, if this happens, blah, blah, blah. The only thing I can do is say, do you know how to type a scientific number into your calculator? Because if you don't, then unfortunately I do have something else I have to show you. But if you already know how to type that into your calculator for atoms, then you're good. Let's do a problem that involves atoms. If I have 22 moles of uranium, how many atoms of uranium do I have? Build your T. Letters, letters, letters. What letters go here? Moles. The given unit always goes in that first square and in that bottom diagonal square. Notice that the numbers don't match. That's another thing y'all love to do. You'll put 22 in both of those squares. No, no, no. The only thing these two diagonals have in common is the unit. What letters go here? The unknown unit, atoms. Everyone cool so far? Now we have numbers. Given number is 22, and I'm just making up these given numbers. Conversion factors. Both of these squares come from my list of 3 up there. Again, I'm going to give you that list of 3 on the test. You don't have to memorize Avogadro's number. What is the conversion factor for moles? It's a 1. What is the conversion factor for atoms? 6.022 times 10 to the 23rd. Now, nothing changes. You need to multiply. You need to multiply and divide. But if that scientific number is going to mess you up, it'll happen right now. On your calculator, I'll show you how to find it. But you can make the screen say a capital letter E. What a capital letter E means is times 10. Now, some of y'all like the caret, and that's fine too, all right? But I don't teach the caret. There's a bunch of different ways to do scientific notation on your calculator. Here's how I teach it. The E means times 10. So with that in mind, follow along. Here's what I'm going to type on my calculator. 22 times, open parentheses, above the 8 is an open parentheses. All right, it's safer to put scientific numbers in parentheses because order of operations can jack with you. All right. 6.022. Yeah, you see that times 10? I've got a letter that can do the times 10. If you push the second button and then the button above the 7, you'll get the E. If you're on a calculator that is not this color, you're on the light blue one, I think it's a non-secondary function. You can just hit the button above the 7. Am I right? Yes. If you are on the other calculator where it's a light blue, it's just the button above the 7 will give you that E. Once your screen says E, you can then put the exponent. You've already done the times 10. 23, close parentheses. Divided by 1. So one more time, my calculator said 22 times, open parentheses, 6.022E23. No times, no 10, just E. If you did it right, you'll get this answer. If you're not getting your calculator to say that, call me over. Let's do another one. If I have 2.6 times 10 to the 22nd atoms of Al3, how many grams of Al3 is that? I'm still working with you, but if you want to try to skip ahead of me, you can. I'll give you a second. If you'd rather not, then just wait 1 second. Be careful, though. I'm going to draw my grid. While looking at my cheat sheet, I'm going to identify my given units as atoms. I know that those given units also go down here. My unknown units go up here, which is grams in this case. I'll go back and input numbers. My given number is 2.6 E22. Remember, E stands for times 10. These two squares are conversion factors from my list of numbers up top. The atoms conversion factor is Avogadro's number, 6.022 E23. The conversion factor for grams is the periodic table, which is a bummer. So is that. We're dealing with Al3. So I'll go here, I'll say I have aluminum. There's 3 of them. All right, this is molar mass. So I'll multiply that times aluminum's mass of, I don't know, 26.982. 3 times 26.982, I get a molar mass of 80.95. Shout at me if you don't like anything I do. Yeah, you don't. What, did you go 946? That's fine. They're both going to get us there. All right, so remember, the whole point of that was that we needed the PT. So 80.9, hello, 46. The biggest travesty in all the world is for you to set this up right, but type it into your calculator wrong. So be careful. Remember, with my scientific numbers, I'm going to put them in parentheses when I enter them into the calculator. It's just safer that way. Here I go. Open parentheses. 2.6 E22. Do not type times. Do not type 10. Just the E. And then the exponent. Close parentheses. Times 80.946 divided by, open parentheses, 6.022 E23. Who's brave? Who's got an answer? Perfect. Perfect. .49 grams of ale. It's easier than Friday, right? Problems are a lot shorter. You'll tear once you get going with these on that new online assignment. You'll knock it out in 10 minutes. You try one. Write this down. I've got my T set up here. It's imperative that you do letters before numbers. Otherwise, you get really confused on what goes where. All right? Remember, my given units will either be grams, moles, or atoms. In this case, it's grams. There's a couple of you that were putting lithium fluoride in there, and then you were getting confused on what numbers you were supposed to put. The compound in these problems, anyway, don't need to go into the grid. A couple units from now, I'll ruin your life. But for right now, it's just the units that go there. Remember, these two diagonals match each other, just like your cheat sheet says. In this case, they're both grams, because that's the given unit. The unknown unit is atoms. Now that we've got letters in all my squares, I can go back and put numbers. The given number is 57.3. And these two squares always come from those three numbers. One of them won't be used. Starting at the bottom, grams is periodic table. That means lithium fluoride's where I need to look. There's only one of them, one per element. So I need the mass of one lithium and the mass of one fluorine. Who's got that? We happy with that answer? I didn't calculate it. All right, so one lithium plus one fluorine, 25.94. Again, we need a conversion factor, but this time for atoms. Avogadro's number, 6.022 E23. Questions, except for the part where I can't draw a 3. I'm going to make a mental note to put that in parentheses when I enter it into my calculator. 57.3 times, open parentheses, 6.022 E23, close parentheses, multiply across the top, divided by 25.94. I get 1.33 times 10 to the 24th. Questions?